In this problem, we were asked to find the equations of the tangent lines of slope minus 1 to the given curve. So the tool that we have to use to find the slopes of the tangent line is the derivative. If we can find y prime, our derivative, that gives us an equation or a representation of all of the slopes of all of the tangent lines. And in particular, we're looking for the slopes that are minus 1. So what we want to do here is find y prime. We want to take our derivative. So we have 2x plus, and then we have a product rule because x times y. So the derivative of x is 1, rewrite the y, and then plus, rewrite the x, and then the derivative of y, we write y prime by implicit differentiation. And then the final term, we have 2y, and then we write y prime by the chain rule. And then on the other side, we have the derivative of 12, which is just 0. So we are looking in particular for when our y prime is minus 1. We'd like to know where that occurs, so we can write down all of these tangent lines that we're looking for. So let's try to write down what happens when we plug in minus 1 for y prime. So we would get 2x plus y, and then the next term would be minus x, and then the final term would be minus 2y. Now, combining like terms, we have 2x minus x, so we have an x, and minus 2y plus y, so we have a minus y. So we're told by what the question gives us that we want points where x equals y. That's where this can occur, when y is equal to x. So let's plug in to our original equation y equals x and see what happens. So going back to the original equation, if we look at x squared plus x multiplied by y, but we're going to exchange y for x, so x squared, and then plus y squared, and again, we'll change it to x's. So we have x squared. All of this equals 3x squared, and all of that should equal 12. So 3 times 4 equals 12, or x squared equals 4, so x equals plus or minus 2. And we can read back upwards through our argument. Now that we found the xy value, we can say that whenever x and y are the same, then reading backwards, then we get back to this original equation here, and we'd have 3x's there, and when y prime is minus 1, then we also have 3x's there, but minus 3x's. So we indeed get 0, and that equation is true. So as soon as we have x equal to y, that is a point where y prime is negative 1. That is the slope of the tangent line at those corresponding points. There's 2 of them, 2, 2, and minus 2, minus 2. So we can use the point slope form of a line and complete our problem. So writing down the equations that the problem is looking for, we'd have y minus 2, we'll use the point 2, 2 first, equals the slope, which is minus 1, and then the x-coordinate, so x minus 2. That's one of the equations of the tangent line, and the other one would be at the point minus 2, minus 2. So we'd write y minus a minus 2, so y plus 2 equals the slope, again minus 1, and then x minus minus 2, so write x plus 2. These two equations that we just wrote down, that one there and that one there, are all the tangent lines to this curve that we were given with slope minus 1.